Section 2.2 is where we're going to talk about complementary and supplementary angles. We're also going to talk about perpendicular lines. So first off, what is a complementary angle? Complementary angles are two angles that add up to 90 degrees. Supplementary angles are going to be two angles that add up to 180 degrees. So here are some examples. These two guys are complementary because they add up to 90. These two guys are supplementary because they add up to 180. Here's another example down here where they are complementary because they add to 90. And another example where they are supplementary because they add to 180. So you can just see that these two sets at the bottom are adjacent, but the top two are not adjacent. But it doesn't matter as long as they add to 90 or 180. So let's use that information over here. So in example 1, it says find the measure of two complementary angles if the measure of the larger angle is 5 more than 4 times the measure of the smaller angle. So the first thing I noticed is the keyword complementary. That means they have to add to 90. Then I see them using a word phrase that they want me to change into symbols. So what I did is I just put the smaller angle as x, and I put the bigger angle as this expression. So 4 times x, 5 more than means to add 5 to it. You can also write it as just 5 plus 4x. Now, if they're complementary, we said they have to add to 90. So I set up my equation where I add x, my first angle, plus my second angle, 4x plus 5, and set it equal to 90. And then I just solve. So 5x plus 5 equals 90, subtract 5, and divide by 5. I always go back and reread the question. It's asking for both angles, so I'm going to plug them into both expressions. So plugging it in here gives me 17. Plugging it into the second one would give me 73. You can always check your math because if it's complementary, these two should be adding to 90. Pause the video and see if you can do the check question. So in the check question, you're now talking about supplementary, so hopefully you use the number 180 this time. And then this one's a little bit different because it's talking about the difference of the two. So what I did is I just set up one of my angles as x, and since it talked about difference, I just did x minus 18 for the second one. So since they are supplementary, those two have to add to 180. So I did my first angle and my second angle and then set it equal to 180. So then I could solve it. 2x and then add the 18 over, divide by 2. I go back and reread. It wants me to find both angles. So if I plug it in there, one of my angles has to be 99. And if I take away 18, the other one would have to be 81. All right, the next part we're going to talk about is perpendicular. So line segments or rays that intersect at right angles are perpendicular. Segment arrays can be perpendicular to lines or other line segments and rays. The right angle symbol indicates the lines are perpendicular. So down here in your picture, perpendicular lines will intersect and form 4 right angles. So they will always put this box in one of the corners, but you can go ahead and draw in all of them because you will know all of those are 90 since vertical angles are equal and linear pairs have to add to 180. The next box is saying perpendicular lines intersect to form congruent adjacent angles. So just like we were getting ready to discuss, if this guy is a right angle, then all the ones around there would have to be right angles as well. In example number 2, it says the tangram is a puzzle consisting of 7 flat shapes called tans, which are put together to form shapes. Find the values of x and y such that AD and EC are perpendicular. So I go to my picture, AD is here and EC is here. So if it's perpendicular, we just learned that you have right angles. And if one of them is a right angle, then all of them is a right angle. So one thing I know is that this expression has to be equal to a right angle, and a right angle is equal to 90 degrees. So that's the first thing I did. I did 3y plus 15 equal to 90. And then I just solved. So subtract and divide, and I got y to be 25. On the other one, which is kind of hard to read in there, you've got two angles inside of there that make the right angle. So I had to add these two in order to get that 90 degrees. So that's how I set up my equation. I added 7x plus 10 plus 8x plus 5 to equal 90. And then I just solved, combined my like terms, subtract 15, and divided by 15 to get 5. Pause the video and try the check question. So in the check question, you've got that picture here. It tells you that these guys are perpendicular. So therefore, this picture over here, this angle is a right angle, and so is it on that side. So I went ahead and set my 4y minus 2 equal to 90 and solved it. And then for these two, since they're both combined together to get 90, I combined them. So I added 5x plus 6 plus 2x to equal 90 and then solved it. That takes care of day 1 for the notes for section 2.2. If you needed day 2, so day 2, still talking about angles, but now we're looking at diagrams and trying to figure out which are true. So in geometry, figures are sketches that are used to depict a situation. They are not drawn to reflect total accuracy. Certain relationships can be assumed from a figure, but most cannot. So from this picture right here, these are the assumptions that I know would be true. I know that all the points in line are coplanar. I know that G, H, and J are collinear. I know that all of these rays intersect at H. I know that H is between G and J. I know that L is on the inside of this angle right here. I know that these two angles are adjacent, these two are linear pair, and these two are supplementary. Let's take a moment and just see which ones are not true, because these are sometimes what kids get confused on. In this picture, you cannot assume that the lines are perpendicular. So lines that appear perpendicular may not be. So for example, it might look like this is perpendicular with this, but without them drawing a right angle, I don't know that. Also, angles that appear congruent may not be congruent. For example, it might look like these two are congruent, but without them putting in those arcs, I do not know that. And then last, segments that appear congruent may not be congruent. So it might look like H is the midpoint where these two would be congruent, but without those tick marks, I do not know that. Over here on the right-hand side, it's saying because points of intersection can be assumed, you can identify vertical angles. So I would know that these guys are vertical angles and left and right are vertical angles. Because linear pairs can be assumed from the figure, you can also apply characteristics of a linear pair, such as supplementary angles. So we've already talked about that these two would be a linear pair, so that means they would have to add to 180. We can assume that these are going to be a straight line. Okay. What we're going to do is come down here to these pictures and see if we can figure out which statements are true and which ones are not true. So here is my picture. First statement, CE and CF are opposite rays. So here is CE, here is CF. In order to be an opposite ray, they have to share the same endpoint and go in opposite directions. So that would be true based off the picture. Letter B, BGC, which is this angle here, and KGC are a linear pair. In order to be a linear pair, they have to be adjacent and supplementary. So it is adjacent, and I see that they are forming a straight angle. So that one would be true. Letter C, ABJ and CBG are vertical angles. I see my X shape right here forming nice straight lines. I have the left and the right, so yes, those are vertical angles. Letter D, BCG and DCF are congruent. I don't have any information saying that. I don't see any arcs here, so therefore that is not true. Letter E. BE is perpendicular with IF. Nope, not true because I would need a right angle right there to show they are perpendicular. Letter F. EBC and GBC are complementary. Nope, not true because I don't have a right angle right here to show that they form a 90-degree angle. Last one, ICH and HCD are adjacent. Definition of adjacent is for them to be next to each other and share the same endpoint and side. They do. They are next to each other and share this endpoint and side, so that would be true. All right, you're going to come over here to the right side and try the check question. Now, one thing I'm going to point out is the question is asking which ones are not true. So which ones can you not assume? All right, so in the check question, here's your picture. The first one we cannot assume, okay? So KHJ and GHM. There's no information that they add to 90. There's not enough there. GHK and JHK are a linear pair. That's true. They're adjacent and form a straight angle. HL is perpendicular to HJ. Here's HL, here is HJ. I need a right angle going from this line to that line, and I don't see it. I see it going from this line to this ray, which is not far enough. It has to go all the way down to HG. So that one would not be true because there's not a right angle there. And then the last two are true. GHM and MHK are right next to each other. They're right there. And then the last one, HL is perpendicular to HM because I've got that right angle. All right, folks, a lot of information in section 2.2 with complementary and vertical angles and linear pairs, and then just interpreting those diagrams correctly.